OK， 可以吗 ？OK， so let's continue. Okay. So obviously from our previous discussion, the issue lies in what pivot to pick, right? If we are able to guarantee a certain ratio, okay, numbers are smaller than this pivot, and a certain ratio of number are larger than this pivot, then we will be will be fine. Okay, the complexity will be guaranteed. Okay. So here's the idea. Okay. Basically, you divide n elements into groups of 5. Okay. This is very, very tricky. Okay. It has to be group of 5, not group of 7, not group of 3. Okay. But anyway, okay. As you will show, as we will discuss later. Okay. So you have like a bunch of 5 numbers. Okay. So find the median of each 5 elements grouped by road. Okay. So what is road? Basically, just like you can quickly examine 5 numbers and determine their which one is the median, right? If you only have 5 numbers, okay, with maybe like a constant number of comparisons, you can tell which number from these 5 elements is the median, right? Okay. So, okay, then you have this each 5 numbers you have its median. Each 5 number you have its median, right? So you have like this roughly n divided by 5 medians. Okay. So the idea, okay, the second step is very interesting. You are recursively select the median of these n divided by 5 medians. Okay? And use that as the pivot. Okay? And from this point beyond, from the third, step 3 to 4 to 5, I mean, steps 3 and 4 are basically like identical to the previous, like a random partition. Nothing, different. So the only difference is the first 2 steps, to be very honest with you. Okay? So why the first 2 steps makes the difference? Let me first use the figure to show what we are doing. Okay? So we have a bunch of numbers, and we are broken this number. I mean, we break this number into group of 5. Of course, there are some numbers that are left here, right? So that's fine. Don't worry about these numbers. They are not going to make create any issue. We can ignore them. Okay? We can ignore these additional numbers here. So then, okay, we go over each group and try to find the median of these 5 numbers. So divide n elements into group of 5s, like this. And then in each group, we find the median. I mean, in reality, you are not doing sorting. You are not really, I mean, you could, but it's not necessary. The whole process here is to find that pivot. Okay, you just to find one number. Okay, so the order of these 5 numbers doesn't matter. The reason we try to, show you like, oh, these numbers, they are sorted, it's just, what should I say, like, it's easier for our discussion. Okay, it's easier for our discussion. But in reality, you only need to know which number is the median of each group. Okay? So for example, say this yellow element indicate it is the median of these 5 elements. And this arrow just means that, okay, these 2 elements are bigger than this element. The top 2 elements are smaller than the yellow element. Okay, their order is not important. In fact, you don't even need to worry about, what should I say, to sort these 5 numbers. You could, okay, because sorting these 5 numbers, it's not going to, what should I say, increase the complexity anyway. Because, for 5 numbers, you only need like a constant number of comparison, constant number of like position exchange, and you can sort them, right? Right? Okay, so yeah, this doesn't change the order, okay, actually. But anyway, so now you have this yellow elements. You have these yellow elements, and each of these yellow elements is the median of its respective group, right? Okay, and then, okay, we want to find the median of these medians. Okay, so we consider these yellow elements. And then, okay, with the same order statistics process, okay, we are going to do this recursively, right? So we are going to use the similar approach to find the median of these yellow elements. So far so good, right? You guys are still with me, right? Right? Okay. Assuming, of course, this is just for simplicity. For discussion, for discussion to make it simplified. Like we are assuming all the median on the left-hand side happen to be smaller than this red element, and all the median on the right-hand side happen to be. I'm sorry. Which is, yeah, I believe like all elements on the right-hand side happen to be larger, or the other way around. Let me check. Yeah, this is. Oh, I'm sorry. I think I made a mistake. Okay, this arrow means that the top 2 are smaller, the bottom 2 are larger. So I think like the arrow indicate like the opposite of what I discussed. So the top 2 are smaller, the bottom 2 are bigger. I'm sorry. Okay. So basically, okay, we assume this left-hand side median are smaller than this red element. Right-hand side medians are larger than the red element. But this is not necessarily the case, right? This is not necessarily the case. As I said, like this is median. I mean, they are really not sorted. These numbers, they are really not sorted, you know. So really like, you know, some numbers here, they may be smaller than this median. Some number here, some median here, they may be larger than this median. But I mean, here for simplicity, just for our discussion, let's assume like it looks like this because like it helps us to for our like a further discussion. So this red element, as I said, is the median of these medians, right? Okay, so if you agree with that, okay, here we will try to use this one as a pivot, okay, as a pivot for the rest of the algorithm, okay? I mean the step 3 and step 4, basically like we'll use that red element as the pivot. So why? The basic idea is like this. Because if these elements, they are smaller than x, okay, and we know that, okay, these are the medians, right? These are the median. So not only these elements are smaller than x, the top 2 of each of these elements are also smaller than x, right? Right? So in other words, this part that marked by purple, these numbers, they must be smaller than x. Is that right? How many numbers are there? Because like this part is roughly n divided by 5 divided by 2, right? Okay, and you know, and we have like you know, so we have this many group medians, and then you know, for each group, at least 3 of them are small or equal to x, right? So it's going to be 3 times n divided by 10. These elements, these many elements, so which is indicated by this purple region, these elements must be small or equal to x, right? For similar reason, this region must be larger or equal to x. Is that right? Is that right? So, then, okay, so for n greater or equal to 50, we have like a 3 times, you know, n divided by 10, okay, floor is greater or equal to n divided by 4. I think this is easy. You can easily check that, okay, check out this thing. I mean, but anyway, the important thing is like this. For n greater or equal to 50, the recursive call to select in step 4 is executed recursively on smaller or equal to 3n divided by 4. Because each time, you know, each time, remember like in our previous analysis, you remember, like when we break the group into 2, when we break the group into 2, we assume the worst case scenario. I mean, that particular number that we are looking for happen to be in the larger part or larger split, right? In a larger group, right? So, you know, But you know, here, okay. If the number is not here, is not in like in this set, it must be in this set, right? It must be in this set. So in the worst case, it's going to be n divided by 10 times 7, right? Yeah, if it's not in here. Or if it's like smaller, then it's going to be, you know, in here, which is n divided by 10 times 7, right? Okay, so basically, okay, the recurrence for running time can assume that step 4 takes time. This one, in the worst case, because like you know, this 3 n divided by 10 to the power times 3. Okay, each time we are able to get rid of like about 1/4 of the elements at least, right? We're able to get rid of at least 1/4 of the elements every time. We call this recursive call. So, you know, so what happens actually? You know, because of this, because we are able to get rid of like 1/4 of the whole of all the elements, so we are able to guarantee like Tn is, you know, is the worst case time is Tn is going to be like it should be linear. Okay, this is some typo here. Okay. Smaller than 50. So the base case is just assume that if it's a base case, for n is small enough, we assume it's a constant. It's constant. So let's again take a closer look at this algorithm, because this algorithm obviously is broken into 4 steps, right? So let's take a closer look at this. You know, complexity analysis. The first one, select In. Okay, obviously, it indicates T of n, right? So first step, divide n elements into group of 5 and find the median of each group. Okay, so as I said, like this division. Okay, and then, you know, for each group, taking constant time to find the median. Obviously, it takes linear time, right? Right? It takes linear time. So that's for the first step. For the second step, you are trying to recursively select the median of all these medians, because you have roughly n divided by 5, these median numbers. So from these median numbers, you are trying to find the median out of these numbers. So it's T of n divided by 5. And then partition the pivot, around pivot x. This partition takes linear time. Okay, we already know that. Okay, and then, okay, in this recursive call, okay, every time we call this recursive call, the n is reduced by at least 25%, right? 25%, so 1/4. So this part is T of 3n divided by 4, right? So if you add them up, so Tn is going to be a linear time plus Tn divided by 5 plus linear time plus T 3n divided by 4. It's going to be the summation of all this, which is what? So, you know, you can use the substitution method. Assuming Tn is linear, Tn is bounded by Cn, and then you use, you try to solve it recursively, use a recursion, okay, or like recurrence, or use like induction. Okay, induction. So this one, Tn is going to be small or equal to 1/5 of time Cn plus 3/4 of Cn plus linear time. And you add them up, it's going to be 19 divided by 20 Cn plus theta n. So it's going to be Cn minus 1/20 Cn minus theta n. So as long as you make C large enough for this term to dominate this one, then we have the case. Okay, this one is going to be smaller or equal to Cn. So we know like this must be, the whole thing must be bounded by linear time, right? So this is a very, very good, right? Very, very good. Because we are not doing average case. We are not doing expected time complexity. We are actually doing worst case analysis here. Okay? So this is very, very important. Okay, so here I'm telling you, okay, for a group of numbers, regardless what rank you want to find, okay, you have an algorithm that guarantee you can find the certain rank in linear time. This is guaranteed, okay? Okay. So far so good, right? You guys are still with me, right? So this finding median of the median, okay, is a very interesting idea. Okay, very, very interesting idea. For example, so the conclusion here, the work at the level of recursion is a constant fraction, smaller. The work per level is geometric series dominated by linear work at the root. Okay, this is like the explanation, I mean, why it is linear. But in practice, this algorithm runs slowly. Why? Because, the constant in front of n, that Cn, that constant C is actually quite large. So in practice, okay, if you want to find a certain rank quickly, then the previous algorithm, the random permutation one, actually work faster, okay, in practice, okay, in practice. But obviously, like when n grows to very, very large, yeah, I mean, this algorithm has its benefit. After all, it is like time complexity is bounded by linear, okay, time. So the randomized algorithm is far more practical, okay, for most cases. For most cases, I mean, if you have limited number of elements, in general, that's mostly like the case. Okay, anyway, okay. And one interesting question that you should consider, okay, here we break the numbers into group of 5, right? Into group of 5. Why group of 3 doesn't work? You could give it a shot and try to analyze it. And you will find that, yeah, group of 3 doesn't work. You need group of 5. That's a quite interesting fact. Okay. So this group of 5 is not, a random, number to come up with, like by those people who invent this algorithm. Okay, so this is like an interesting work for you to think about. So this I'm going to ask you why not divide into group of 3 in the homework exercise, okay? Homework assignment, okay? I'm going to, in homework assignment, this is one question. The other question is this one. This one. I want you to test why this is the case. Okay? So, yeah, we are done for this one. Okay? Let's take a break. When we come back, I'm going to just to give you like a head up for what we are going to discuss like in next chapter. The next chapter is going to be about hashing. Okay, so we are pretty much done with like the sorting part. Okay, including this rank or like order statistics. Okay, but the next topic is hashing. So hashing, we will talk about hashing. I don't think we are going to, because like next week we have we don't have class, right? Next week we don't have class because of the spring break, right? And the week after next is going to be the midterm, right? So, which basically means that, okay, yeah, I'm going to talk a little bit about like a hash today, but obviously like I won't be able to finish like enough material for your midterm. Okay, so yeah, I mean, the midterm will cover everything from the beginning of the class to the order statistics. Okay. So you need to remember like what will be covered by the midterm. Okay. So by the way, like the sample meter I gave you, the range may be slightly different. So you know, if you feel like, oh, how come? I mean, this problem is not covered by our class. Well, that's because I mean, you know, we are different class, right? I mean, the semester is different, so like the progress will be different. So yeah, but the simple midterm is just to show you like what type of question I mean will be asked in the homework in the midterm. Okay, it's not really like you know, I'm not going to repeat the same question. I'm not going to, you know, the range may be slightly different, but it just gives you like a head up, like what kind of question I may ask in the midterm. Okay. So let's take 10 minutes break. When we come back, okay, let's spend some time on the hash, which will not be covered. Let me repeat, it will not be covered by the midterm. Okay, but yeah, I mean, because we still have like an hour of lecture.